All right, hi everybody, welcome back to this channel. Thank you very much for joining us once again. If you're new to the channel, guys, please ensure that you have subscribed, turn on that notification bell so that you can be notified every time when we drop a new session. I know it's been quite some time without uploading. It's been a bit hectic, but we are back at it again, guys. It's application of calculus. Remember, we have a session specifically for application of calculus, right? Because it's one of the topics that most of you find it a bit challenging, right? After you do calculus, you do application of calculus, optimization, maximization, and minimization. Okay, we have a session specifically on that, right? Covering a whole lot of dimension, and there's been quite an exciting feedback that we received from it. Most of you indicated it's quite insightful, very helpful, and has opened really your eyes to really believe that indeed this topic is really learnable and it's fairly easy. All right, so I'm just gonna drop the link of that session on the description in this video. You can go and watch it if you haven't watched it, right? Or if you want to do revision on application of calculus. Okay, so in this session we're going to look at this interesting question adapted from I think it was the Gauteng trial exam paper. Quite challenging really, application of calculus, very different from at least most of the example that we treated in the application of calculus session. Okay, because this requires more than just knowing the procedure on how to generate the mathematical equation, but it requires some skill of imaginative and creative thinking. Okay, in order to solve it, hence it's a bit challenging. All right, but before wasting any time, guys, let's go straight onto it. Okay, they are saying a hotel has 72 rooms to let to clients. The daily rent per room is 500, right? So we do know that the rent is 500. If the rent is increased by 100 rand per day, there's something interesting happening here, right? If the rent is increased by 100 rand per day, 2 rooms can be left vacant daily. Okay, so it's very important to highlight that. Okay, so the rent is X rand per room per day, where X is greater than 500. Okay, something very interesting is happening. It seems that their daily rent is increasing, right? Because remember, they're saying the rent per room per day is X rent, right? Yeah, they showed you that actually the rent is X rent per day, but we are told that the original rent actually per room is what? It's 500 rands, right? But it seemed like it's increasing because they showed us that this X is greater than 500. Okay, but we know that when that X, which is the rent per room per day, it has increased by 100 rands, right? There will be 2 rooms that will be left vacant. So you'll have 72 minus 2, which is 70 rooms that can be occupied. Okay, so that's the notion really. So the question is saying you have to show that the total income will be given by I equals to 82x minus x squared divided by 15. Okay, so that's the expression we want to really generate, or rather mathematize and model. So how do we generate the income as given in this question? How can this company or hotel generate its income mathematically? All right, I mean, what is the mathematical expression for the income of this hotel? Okay, so we do know that the income will be dependent on the number of occupied rooms multiplied by the rent per day, right? So we do know that the expression of the income will be equals to the number of occupied rooms. How many rooms are occupied, right, on that day? Remember, this is an expression of daily income, right? How many rooms are occupied, the number of occupied rooms on that day, multiplied by the rent per room. Okay, so that will give us the total income that this hotel can generate. Okay, so we already have an expression of the rent per room. It's given in your equation here that the rent is X rand per room per day, right? So it's X rent. So we do know that X is equals to what? The rent per room per day. Okay, so you have the expression of rent per room per day, which is X. So our income will be the number of occupied rooms, right, multiplied by what? Multiplied by X. So to finally generate, to show that the income will be 82x minus x squared over 50, we do need to go and check what is the expression, mathematical expression for the number of occupied rooms. Or in this case, let me say I equals to nx, okay, where n represents the number of occupied rooms and x obviously is the rent per room per day. Okay, so we need to get an expression of n, right? What is n? What is your number of occupied rooms? And that is what is quite tricky in this question, to get that expression, because there's something happening here that when you increase that rent by 100 rand, you'll have 2 rooms that will be vacant, right? So if the rent is actually 500, we do know that the n, number of occupied rooms, you'll occupy the 72 rooms. Okay, but the moment this x, right, remember this is our x, which is the rent per room, the moment it is increased by 100 rand, when it goes to maybe 600, what happens? This number of rooms then decrease by 2. Okay, and we are told that this x is not a constant, it is actually increasing somewhere somehow, because they say x is greater than 500. It means that there's no person who's gonna pay 500, right? They have to pay more than 500. So daily this rent, it's increasing, it's inflating. Okay, so we need to get that expression that of n, number of occupied rooms, that will be able to certify this condition such that as it is increasing, when it reaches 100 rents, there are 2 rooms that will be vacant. Okay, so we do know that so far n is equal to 72 minus, right, minus 2, but we do need this expression here that will ensure that as that x is greater than 500 and it increases by 100, then we do have that 2 rooms that will go away, right? Okay, so we need an expression there. So to find that expression, really, it's quite a bit tricky, right? But we do need an expression because x is greater than 500. We need to know, right, the expression of an increase in rent. Okay, what is the expression for increase in rent? Okay, so obviously if because we do know that at 500, 72 rooms will be occupied, right? And we also know that for every 100 increase in rent, there will be 2 rooms that will be what? That will be vacant. Therefore, the expression for the rent, we know that it is x, right? X is the rent, but the increase, right, from 500, from this 500, if I want to know the increase from 500, obviously it will be what? We'll take that x minus what? 500. That will give us an increase from 500, because we do know that x is greater than 500. So for example, if we want to calculate an increase and someone pays 501, obviously an increase from the original 500 will be 501 minus 500, giving you 1 rand increase. Okay, so hence you are saying an increase in rent. So the increase in rent. Okay, so we can find it by saying x minus what? 500, because we are increasing from 500 and x is greater than 500. Okay, so this gives us an expression for the increase in rent. Okay, so but then how do we consolidate? How do we ensure that when this is increased by 100 rand, right? When this increase is equals to 100 rand, then we do know that there will be only 2 rooms that will be vacant. Okay, how can we ensure that? So we can say x minus 500 when it is equals to 100, right? Because we want to ensure that only 2 rooms will be vacant when for every 100 rand increase. Okay, so we can come to this expression here to say x minus 500. Okay, so the moment you do that, right? So if you check, if I want this factor to be 1, this factor here inside to be 1, such that when you increase by 100, only 2 will be subtracted, then you do know that you have to divide both sides by what? By 100 here. Okay, so that this factor here can actually be equals to what? Be equals to 1. So you do know that if you say x minus 500, which is the increase in rent, the moment it reaches 100 rand, when you divide 100 rand, the factor is 1. Therefore, this 1 times this 2, you ensures that only 2 rooms are vacant. Okay, I hope you understand that, because it's very, very important to get that sentence. It's a bit tricky. Okay, so we are saying, guys, that the increase in rent, when it is when the rent increases by 100 rand, 2 rooms will go away, right? So we know that number of rooms occupied n is equal to 72 minus 2 for what? For every 100 rand increase. Okay, if you increase by 200, obviously you subtract what? 72 minus 4. But we do want a mathematical equation that ensures that that is the case throughout, right? So I'm trying to find an expression here that when we put there, it will ensure that continues like that. In other words, that expression that I must put must be of a factor 1, so that when you say 72 minus 2, you know, times 1, do you understand? It will be like you are subtracting 2 rooms are becoming vacant, right? Like that. So that is what we are trying to get. So then we understand that from 500, the original rent is 500, x is the rent, that must be greater than 500. Okay, so in order to calculate increase, we are saying what? From 500, the increase in the rent increase will be x minus what? 500, because x is greater than 500. Okay, so it means your x can be even 600. Do you understand? 600 minus 500, then you can find, oh, the rent actually increased by 100 rand from 500. Do you understand? We are saying from 500 because 500 is the original, so this is the increase, right? So that is the increase. But we want to ensure that when this increases by what? 100 rands. Hence I'm saying x minus 500, the increase, the rent increase, when it is 100 rand, then we ensure that 2 rooms are what? Are vacant. Okay, so I need to ensure that the expression that I write here is to the factor of 1. That will actually ensure that these 2 will be multiplied by, you will be like you are multiplying with 1, ensuring that you actually make 2 rooms to be vacant, so that that expression remains correct. Okay, so from this notion of you increasing the rent, this is the rent increase when it is 100 rand, right? We want to ensure when it's 100 rand, only 2 are gone. So to make that expression to a factor of 1, I can divide both sides by what? By 100. Okay, so if I say this expression now, 100 over 100 is like 1. it is to a factor of 1. Do you understand? So if I come and put it x minus 500 over 100, you have now actually ensured, this is like you have put 1 there. Can you see? It's like you have put 1. This ensures that for every increase of the rent by 100 rand, only 2 will be vacant, because it's like 2 times 1. Do you understand? So that's the notion there, and we can actually prove it. If you come and increase, maybe your rent is now 600. So if you say 600 minus 500, right, it will give you 100 over 100. You understand? Times 2 there. Then the number of rooms that can be occupied, you realize, is 72 minus 2, which will give you 70 rooms, right? If you increase, maybe let's say 700, so you'll understand you are increasing that factor now, and it aligns with this thing. So it will be minus 2 into, it will be 200 over 100, right? 72 minus 200 over 100, then it's 72 minus 2 into 2. Then do you understand? When you increase by 200, 4 rooms will be vacant. As you can see in this expression, it will be 72 minus 4, meaning that expression there, it is correct. It's a bit tricky, guys. I do know it's a bit complex to comprehend, but that's the notion really to say, because they told us when you increase the rent by 100 rand, 2 rooms will be vacant. So this expression here allows you to have an increase, right? To say when it increases, but we are restricting here by dividing by 100. We are saying, but when this increase by 100, then how do we know that we are restricting by 100? By dividing by that thing. You understand? By dividing by 100, we actually restrict that to say when this increase by 100, only 2 will be vacant. It means when this increase by 200, 4 will be vacant, like that, like that. Okay, if they said when the rent is increased by 200, 2 rooms become vacant, obviously here we're gonna divide by what? By 200. Okay, but we are dividing by 100 because we are restricting to 100 to say when the increase, this is the increase in rent on top, but when it is increased by 100, we ensure we multiply by 2, saying that only 2 rooms will be vacant. So that's the notion really, and you see this thing is like we are multiplying by 1. Okay, so that is it. Now we can finally go and find the expression of I, because I, which is the income daily in this hotel, will be the number of rooms that can be occupied as expressed here, multiplied by the rent per room. We are told that the rent is X rent per room per day in the statement. So X is your rent per room per day. Okay, the number of rooms expression, we have found it, there it is. So I'll go and say we have 72 minus 2. Maybe we can first simplify it, right? And substitute it when we have simplified. So in 72 minus, so this will be 2x plus 2 times minus 500. I mean minus 2 times minus 500 will be plus 1000. This is divided by what? By 100. So n will be 72. If we divide everything by 100, this will be x over 50, right? Then plus 1000 divided by 100, it will give us 10, right? Plus 10. So if we simplify, our n will be 72 plus 10, it is 82 minus x over 50. I hope you can see that. Or maybe let me write it some on top. So we are saying n is equals to 72 plus 100, which is what? 82 minus x divided by 50. Okay, so that is the expression of the number of rooms that can be occupied. So we can now finally go into this expression. The income is equals to the number of rooms that can be occupied multiplied by what? Multiplied by the rent per room per day. Okay, number of rooms that can be occupied, we have the expression which is 82 minus x over 50 This is multiplied by the rent per room per day, which is your x. Then x times 82 will be 82x. Then x times this one will be minus x squared divided by what? By 50. Okay, which actually gives us that expression. So we have shown that the income is 82x minus x squared divided by 50. All right. Okay, let us now look at 10.2. Right, we have shown that the income is equals to 82x minus x squared over 50, which was your 10.1. 10.2 is now saying calculate the maximum daily income per room. Right? Okay, you recall really from application of calculus lesson that how do we know we have to maximize? How do we know we have to minimize? Key terms, right? In this case, they want the maximum daily income. So the keyword there is maximum, right? The moment we see that, we think of optimization. How do we get the maximum? How do we get the minimum? We recall this knowledge from our calculus function, right? Cubic function, that we do know that at the maximum, which is our turning points, we know that the first derivative is equals to what? 0. First derivative is equals to 0. With that knowledge, we know that what we have to do, we must have our expression, right? Our equation that will go and derivate and equate to 0 and solve for those x that will actually ensure that we are either maximizing or minimizing. Okay, so likely we have already generated an equation, right? Even if you were not able to generate this equation in 10.1, but you can see that this 2 mark, you can easily get it because you have the expression already, right? Expression of income in terms of x, which is like 82x minus x squared divided by 50. We do know that to get the maximum daily income, okay, so what we have to do is we have to go and find what? First derivative of this. Okay, maximum daily income per room. So we need to solve for x because x represent your daily income, the rent per room per day. Okay, so how do I get the derivative of this? 82x, the derivative of that is what? It's 82, because you know 1 at the exponent to multiply 82, then you go and subtract 1, you have 82x exponent 0, which is just 82. All right, so the derivative of this is like 1 over 50. Okay, x squared, so the 2 will go there, multiply with 2, then on the exponent you subtract 1. Okay, so 2 minus 1, you'll be left with 1. 2 over 50 like that, so it will be 82 minus 2 over 50x is equals to 0. Remember, we say first derivative must be equals to 0 because at the turning point, first derivative is equals to 0 on your cubic function. All right, and that's where the maximum is, or that's where the minimum is. Okay, now we can solve for x by either taking this portion to this side, then we have something like 2 over 50 x is equals to 82. Then to solve for x, I can divide by 2 over 50, which is like 1 over 25, or rather multiply by the reciprocal of that. Okay, I can just come and say multiply by 50 over 2, right? Both sides, what we do on the left must be done on the right. Multiply by 50 over 2. This cancel this, then you have your x is equals to 82 times 50 over 2, so which is like 82 times 25. We can quickly do that on a calculator. So we are saying 82 times 25. So the maximum rent, remember this rent has been increasing because they told you x is greater than 500, so daily this rent was increasing, right? So but the maximum, it will be 2050 rent. Okay, can you see? So as much as it's increasing, x is greater than 500, the maximum it can reach is 2050 rent. Okay, I hope you find this helpful, guys. Don't forget, if you haven't watched the application of calculus, our first session on application of calculus, where we cover a whole lot of dimension of examples and all that. If you're struggling with the topic, please click on the description of this video. I've put a link for the application of calculus session. Very quite exciting and interesting. Okay, I hope you find this helpful. Don't forget to subscribe, like, share, and comment. And let's see you next time. Thank you. Bye.